Welcome everyone to the second episode of the Security Plus video podcast series for Blacks in Technology. My name is Greg Greenlee. We are going to be talking about some things we didn't get to talk about last episode. One of the things that I wanted to touch on was that I didn't get to touch on was what is the Security Plus certification and what's it about? What can it do for you? The Security Plus certification is a vendor-neutral certification that covers general security topics. Vendor-neutral meaning that it's not bound to any vendor. It's not like a Cisco certification. It's not like Microsoft or Red Hat or any vendors like that. So it covers general security topics that can be applied to a lot of aspects of information technology. And it builds a real strong foundation as far as security goes. I think a good foundation is key into actually building your knowledge base and growing more. If you don't know the basics, then how are you going to know the more advanced topics later on in the future? So again, we're using the Daryl Gibson Security Plus Get Certified, Get Ahead book, and really good book. I think last time we left off with some of the core security principles. We were talking about non-repudiation. I think we talked about CAIN, which is CAIN, which is confidentiality, availability, integrity, and non-repudiation. We're going to start off with talking about defense in depth. I took some notes here. And basically, what is defense in depth? Well, if you go by the saying that security is never done, it's updated and improved. Defense and monitored and improved. Defense in depth is basically a layered security. So you're not just implementing one layer of security, such as just a firewall. You also have a firewall, maybe an IDS, or maybe that firewall contains an IDS and IPS. Antivirus. Multifactor authentication is included in that as well. So you have several layers of defense when you include multifactor authentication, because then you have what multifactor authentication is. It's just basically what it says. There's several layers of authentication that you must go through in order to gain access to something. When it's something, for instance, like a data center, I work at a data center. We use multi-factor authentication just to gain access to our data center. For instance, we have a key card. Well, the first layer of defense in our data center, for instance, is our key card. It gives us access to the actual building. Our second layer of defense is a pen-operated elevator. Meaning you have to put in a code in order to get to the floor of the data center. After that, there's biometric. There's a thumb scanner or fingerprint scanner. So after that, then you actually have to have a PIN number in order to even get inside the actual data center itself, where all the servers are housed. From there, there's another PIN number that you have to input to gain access to your cabinet. So that's basically what it means by multi-factor authentication. You got pins and passwords. You got biometrics in the form of palm or fingerprint or even retina scanners. You have key cards or key fobs used in multi-factor authentication. So that ties in with defense in depth, because with defense in depth, you want more than just one layer of security in order to secure whatever it is, if it's data or if it's physical access to a server or network appliance or anything like that. You want to have several layers of security. Then the book goes to talk about the implicit deny. And basically what the implicit deny is, unless something is explicitly allowed, it's automatically denied. For instance, if I set up a firewall, and I set that firewall to explicitly allow, I should say, HTTP or port 80 to a certain server. That basically means that I'm allowing any traffic going to port 80 to that server. All other traffic going to that server is denied. That's basically what an implicit deny is. It means that if I don't explicitly allow the traffic, then all traffic is denied. Another thing they talk about is use devices as intended. And what does that mean? Well, it means exactly what it says. You want to use the devices as intended. If you have a web server, what you don't want to have is a firewall. You don't want that web server acting as your firewall. Or you don't want to have a file server acting as, let's say for instance, your Active Directory server. Why is that? Well, if one of the actual services on that server is compromised, it could bring that whole server down. So say for instance you have your web server and your firewall are on the same server. What happens if that web server is compromised? Then there goes your firewall as well. And then people will have access to whatever because now your firewall is down. So that's basically what use devices as intended means. It basically means use the devices and the servers for the roles in which they were intended. Next thing is we talk about is authentication. And we talked a little bit about that in the layers of defense. Authentication is used to prove identity through the use of some type of credential. A lot of times it's a username and password to authenticate. Sometimes it's a key card or a key fob that you can use to authenticate. The actual weakest out of all those is actually a username and password because a lot of people write their passwords down or something like that, and it's easily passwords are easily can be easily found out in situations like that. The three factors of authentication: something you know, something you have, something you are. Something you know, such as a username and password or a PIN number. Something you have, a key card or smart card, is they also call them. Something you are, fingerprint or retina, some type of biometric identification, and that's considered the three factors of authentication. It then goes to talk about passwords, and that's really, really important because a lot of people, being in the information technology field, I've witnessed a lot of people using weak passwords or using passwords and writing them down. Passwords should be strong. They should contain alphanumeric characters. Should be at least 8 characters long. Shouldn't be just something that includes your username. Shouldn't be written down. Don't write your password down. That means anybody can come by and use your password to gain access to whatever you have access to. Shouldn't be shared. So don't go telling your passwords to people who shouldn't know your password. Passwords should be regularly changed. That's key because you don't want to continue to use the same passwords. And for instance, if you have a team of network administrators or server administrators, and say for instance the administrator's password to Active Directory or something like that, everybody kind of might know that. If that's never changed and somebody gets fired, that person can easily get back onto that server and wreak havoc. So you definitely want to change your passwords. Passwords shouldn't be reused. Should be an account lockout policy, and default passwords should be changed. Any default password on any device should automatically be changed. Most devices come with a default password. Change it as soon as you set up. I think that's all we have time for this time. Tune in next time as we continue on the Security Plus track. Again, my name is Greg Greenlee. Thank you for viewing and see you next time.